Hello and welcome to the video covering vectors in R. In this video we will first begin by looking at the four different types of vectors. Then we will look at some common functions that are used to identify different types of objects. We'll also look at indexing a vector and then what happens whenever you combine vectors of different types. So let's begin by creating some example vectors. And we can see that with x, it's going to be double or numeric, which are the most commonly used. If you're just going to be using some numbers with decimal places involved. Y is going to be an integer, so notice that it was created using a colon, so it's a series of numbers. Whereas with x, whenever we created a numeric vector, we had to call upon the concatenate or combine function, which is why you see the C with parentheses and then the number inside. Next, if we take a look at the Z vector, we've created a logical vector here, also using the concatenate function, and then inputting true or false in each of those element places. And the last vector created is stock.symbol, which is going to be a vector of characters, and these are names of companies that have different stock prices, which all of these vectors will be a part of whenever we get to the example and actually rename some of the other ones. But to keep it simple, we're just using X, Y, and Z to be able to manipulate them. Now, although the type and size of objects are shown in the environment window, we can also call upon some commonly used functions in R to come up with what type of variable we have or what is the size. So for example, if I wanted to come up with the type of vector for x, I could simply use type of, and when that is run we can see that it is double, which in the environment window it comes up as numeric, but those are going to be the same thing. You can also use the structure function, which is str. So if I use strx, you can see that it's going to give me what type of object it is, so it's numeric, as well as how many elements are in it. So it says 1 through 4, and then it gives me some of the beginning elements of that vector, which would be all the same information that you would find in the environment window anyways. Now if you just simply wanted to call up how long a vector is, you can use length. So if we called up length x, it will just return 4. And another function is the dimension function, which is dim. But if I run that on x, which is a vector, you'll see that it returns null. You should keep in mind that the dimension function should be used for objects other than vectors. The next topic we'd like to take a look at is going to be indexing vectors. So let's recall x is going to be these 4 elements here, and let's say that I wanted to call upon the second element. So I wanted to call up the 53.23, or let's say I didn't know what it was and I just wanted to call up the second element. So to do this, you would call upon the object and then use brackets with whatever your index was going to be. So I would use x bracket 2, and it will return that second element. Now let's say I wanted more than one element. Well, to do this, I would have to also call upon the concatenate function. So if I wanted the first and third element, I could simply use the concatenate function to use 1 and 3. Then that is going to be an input as my index into x, which you can see returns the first and third element. If I wanted to return a series of elements, let's say I had a vector of length 100 and I wanted the 80th through the 100th element, I wouldn't want to put in 80, 81, 82, 83, 84 all inside the concatenate function and then have to put commas between each one. So something more simple, let's say we wanted the second through the 4th element of x. Well, to do that, you can just put a colon in between the 2 and the 4 and index all of those elements in one call. Much more simply than using the concatenate function. One other thing is that you could use logicals to also index into a vector. So for example, if we called upon our logical z to index into x, and you can see that, well, with z, if I call it back up, it will allow us to retrieve the first, third, and fourth elements out of x, which you could also do by simply saying x minus 2 to remove the second element, and it will return the same thing. Now, another thing to keep in mind is if you combine vectors of different types, then there are some default results which occur. For example, if we were to add x and y, x being numeric and y being integer, then notice that you can see that sum xy is numeric because by default numeric is going to take the place of integers. Now if instead we add together x and z, which means that we would be adding together numeric and logical, the result would again be numeric. So sum xz, you can see in the environment window, is indeed numeric, and that's because z could also be considered 0, 1. So where z is true, false, true, true, you could think of that as 1, 0, 1, and 1. And the result then would end up being as shown in the environment window. If we were to add integer and logicals together, like in y plus z, you can see it ends up being integer. So again, the logical would be viewed as 1, 0, 1, 1, and then add to the integers, which were in y, you would just simply be adding 1 to the first, third, and fourth element in y, and then just returning the second element in y as it was. So by default, numeric is going to replace integer, which replaces logical. So if we were to add up x, y, and z, we could see that sum x, y, z as shown in the environment window is still numeric. And it's important to keep these things in mind because if you start to add together these different types and certain functions are only going to take inputs of a certain type, then just be aware that by combining these vectors of different types that by default something is going to occur. Now it's not really common that you're going to be adding together something like a numerical result with a logical result, but it is more common to simply treat logicals as numeric. So let's recall that z was a logical vector of true, false, true, true, and what if we were interested in the question, well, how many true elements are there in z? Well, with the simple example, we could clearly see that there are 3, but if it was a much, much larger vector, something of length 1,000, then we could answer this much faster by simply calling upon sum function. Notice that because it's a function, I want to use parentheses. So if we sum z, notice we get 3 because it's treating each of the trues as 1. Or another question might be, what proportion of z elements are actually true? If we had this question, then what we could look at is the sum of z over the length of z, which in this case would return 3 out of 4. This concludes the video on working with vectors in R. We hope you found this useful, and happy coding.